So this is again a very simple program to learn some basics of programming, and in this program you will learn, or you will see a simple class called Olympics, and you will find out how we can store objects of this class to an array. And well, we will also learn some basics of or some basic information about Olympic Games. So this is our lesson today, and I have already downloaded the file. If you want to find the file, you can find it when you first go to naturalprogramming.com, and when you click this icon, you will find this page that looks like this, and there you will find the Olympics.java. You will find it there, and by control clicking or right clicking you can download it to your own computer. And I have already downloaded it, and I can also run the program. So if we run the program, so it will behave like this, that if actually you have to use the Olympics data finder to run the program. And so the program says this program can tell you where the Olympic Games were held in a given year, and then it asks the user to type in a year. So I will type a year, so like 1984. And then it says in 1984 Olympic Games were held in Los Angeles, USA. So it works like this. So you can get some basic information about Olympic Games like this. The games in Great Britain 2012, and well, if I give it a year that is no Olympic year, it says that sorry, no Olympic Games were held in that year. So this is basically the program, how it works, and I have already it open in an editor. So let's see the source code. So there are again some comments at the beginning of the file, but here you will find then the actual class. So here is a class Olympics. So this is the class Olympics here, and then there is another class called Olympics data finder, and this is just another class that stores the main method or contains the main method. So, and in this Olympics class it's again so that there is the keyword class, there is the name of the class, and then there are the opening brace, and inside these braces we have the members of the class. And this class has now 3 data members or data fields. So it has the Olympic year, the Olympic city, and the Olympic country. And the year is then of type int, integer, and the other members are strings. So there are 3 pieces of information inside an Olympics object, and then there is a constructor, and then there are 2 methods. One method is get year, and the other method is print Olympics data. Like this. And so for the constructor, you simply have to give this information about Olympic years, so that you first give the year, and then you give the city, and then you give the country. And the program simply copies all these pieces of information to these data fields or data members. So this is a constructor, and remember, constructor has always the same name as the class itself. Constructor doesn't have a return type, but otherwise a constructor is like a method, and it is executed when an Olympics object is created. And then there are these two methods. The getYear method, it simply returns this data member. This data member is returned to the caller. And then print Olympics data, it prints a line of text like this. It includes, it has these strings, and it prints the Olympic year, the Olympic city, and the Olympic country. These data fields, it prints them inside these texts, and so we get texts like these. So, for instance, on this line, this is the Olympic year, this is the Olympic city, and this is the Olympic country. And you can find, for instance, that there is this piece of string here. It is here. So this is basically the structure of this class Olympics. And then we have this other class, the Olympics data finder, and it has only the main method, the static main method inside it. And here we specify first an array. We specify an array that will contain the Olympics objects. And again, it is important to see that here we just first create an array, and this statement really, it doesn't create any objects. So this creates the array that can store maximum 40 Olympics objects, but it doesn't create the objects yet. And the type of the array is then written like this, that there is the type, the class name, and then a pair of empty brackets specifies that it is an array, and then we give the name like this. And it would be possible again to specify this in separately, so that we would first specify the possible reference to an array, and then we would write it like this. But usually it's common to combine these two statements like this. So this one statement does both. It specifies the name that refers to an array, and it also creates the array. Sorry. And then I have this long list of statements. So these statements then create the Olympics objects, and then they are, or references to these objects are then placed to the array. So that, for instance, this statement, it creates this statement creates a single Olympics object first, and then it places this, or places a reference to this object to the first position in the array. So this index value 0 refers to the first position in the array. And index value 1 refers to the second, and index value 2 refers to the third, and so on. So it is a normal array, but now it is just storing objects or references to objects. And so here I create all the objects, an Olympic object for each, for every Olympic game that has been played. And so it is quite a list. It's quite a list. There are no Winter Olympics there, and then there is this. At the end of the table, I put, or as the into the index position 28, I put this kind of object that has the whose Olympic year is 9999, and the strings are like this. So this is just a way to mark the end of the array, or it's a way to mark the end of data in the array. Well, this is a little bit stupid way to do it, but when you do the exercises related to this program, you can correct this, that we don't then need this kind of stupid Olympics object there. So, and after these Olympics objects are created, then we begin the actual source code that does this thing, that it can search for an Olympics. It can search for Olympics data in the array. And so in this program, first the program asks the user to give a year with 4 digits, and well, it also specifies this keyboard object, and then it here it reads the year from the keyboard. And then we use an index variable which we set to 0, and then we use also a Boolean variable to control if the table search is ready or not. Table search can become ready when the Olympics data is found, or when we reach the end of the array and without finding the data that we were looking for. So we have a while loop here, and the condition here is that as long as the value of this variable is false, we will continue. And then we do so that we read 1 year from the array. So this now works so that this refers to the one Olympics object in the array, and the value of the index specifies which object we refer to. And at the beginning, when the index is 0, we refer to the first object. And then, in relation to that object, we call this getYear method. And this then returns a year from the object inside the array, and then that year is compared to the year that is given by the user of the program. And well, if these years match, it simply means that we found the object that we were looking for. So then we do so that we just again refer to the same object with the same index, and we call this print Olympics data method. And that method then prints the one line that gives information about the Olympic Games. And then we set, because we have found what we were looking for, we will set the value of this variable to true, which makes this while loop to terminate. And then if this wasn't true, if the given year wasn't the year of the object in the array, then we compare to the year to this special year 9999, which marks the end of data in the array. And if this is true, if the year is 9999, it means that we have reached the end of data in the array, and we have not found the games that we were looking for. So then we simply say that, sorry, no Olympic Games were held in, and we print the year that was given by the user. And again we set this table search ready to true, because that really happened that it is now useless to search for more data, because that was the object with the year 9999 is the last object in the array. But otherwise, if none of these is true, then we just increment the value of the index variable, and then we start this whole thing again. So this is the search method, how we search data from the array. Yes. Actually, we could then take a look at the how this array is organized in the computer memory. So if you have my book, or if you go to the sample pages of my book, so you can find through this link, you can find sample pages of my Java book, and if you go to this classes and objects explained, you will find a PDF document that I have already opened here. In that PDF document you will find a picture or drawing like this. This is a black and white drawing, and it describes, it looks like, the whole drawing looks like this, and it describes how this array and these objects, how they are positioned in the computer memory. Because it's very important to realize now that when we have we have here an array of objects, and the array itself, it is an object. And then when we store Olympics objects to the array, so we will have very many Olympics objects in the computer memory. And also, as strings are objects in Java, there are also these string objects, and they are also in the computer memory. So basically what happens is that here we create one object, the array object, and these also represent objects, these strings like these, and then we create the Olympics object. So basically, this is a very complicated picture, but basically we can think that the computer memory is organized like this in this case. That first we have a single reference to the array here. And I have again invented these hexadecimal numbers here. They certainly look complicated, and they are fictitious in this case. But these numbers, hexadecimal numbers, now describe memory locations, so that we can. I think that here, when the array is created, the array itself, it looks like this in the computer memory. So there would be 40 positions to store a reference to an Olympics object. And the array address of this array is then stored to this variable called Olympics table. And then when we add the when we create the Olympics objects, it is things would work so that, for instance, here I would have the first Olympics object, which is the first games in Athens, Greece. So because if we think that also the strings are objects, so then we would have a string object that would contain the text Athens, and then we would have a string object that would contain the text Greece. So inside the Olympics object, which is this, that would then have references to these string objects, and then it would have the year as a real number. So the address of this string object would be there, and the address of this other string object would be there, like this. And then the address of this Olympics object is stored to the first position of the array, and the address of the array is stored into this variable. This certainly looks complicated at the beginning, and all these hexadecimal numbers, they are not so beautiful, but I think if you spend some time to try to understand this, you will learn a lot how Java uses memory. And of course, it's also true that I'm not completely sure that how the actual computer, how it uses the memory and in which order it puts the objects. But it doesn't harm anything if you study this and just discover the logic how this memory is used. So you can see, and it's also impossible to describe the whole thing here. So I have only two Olympics objects here visible. So here is the first object, and here is the second object. And also the address of the second object is then stored into this array, like this. So this is how memory is used by Java, or the Java virtual machine. We could then also take a short look at the comments that are here, because this is a little bit, this is one way of creating objects and put the objects to an array. But this is not necessarily a good way, because always you have to write all these index values like this, and so it's a lot of work. So there is also an easier way to create an array like this. So, and that's shown at the end in comments at the end of the program. So there's an easier way. And in this case, we create an initialized array of objects. And as you can see, it's not necessary here to mark the indexes here or write the indexes here. So it automatically makes so that when I here create an Olympics object, and here I create another Olympics object, and I separate these with commas, the system automatically places these objects so that this will be in the index position 0, or this will be the index position 0, and this object will be in the index position 1, and this will be in the index position 2. And it makes it so that the last object will also have some index, and it automatically makes the array such that its size will be such that, or its length will be such that all these objects fit there, and there will be no unused positions in the array. So if I copy, I can show you that this really works. So I can copy this from here. I can make a copy of this. Command C is the copy command, and then I will overwrite this existing array with this new. I will copy it like this. Now it should be the same, but I will store or save the file, and let's recompile it and see if it works. At least it compiles. And let's take, well, I'm from Finland, so let's try this. So in 1952 Olympic Games were held in Helsinki, Finland. And if we try again, in 1940 no Olympic Games were held because there was the Second World War going on. So this is basically the program, and I have exercises you can find if you go to the page of my book and you click this link here, you will find exercises related to this program. So, well, thank you for your attention, and we'll meet in some other video. Bye.